don't think there's much more in Chapter 1 that I want us to step through. All the introductory chapters. I want you to read the chapter, but we are going to skip ahead and get into the good stuff, the programming. So, now that I've said that, I do want to eyeball and make sure that there's nothing else I want to talk about in here. Alright, programming languages. You start off with an algorithm, which is a set of well-defined steps. It's a recipe for solving a problem. You want to calculate pi? Well, here's a formula that'll calculate pi for you. That's your algorithm. It's not a program. And then your code is an expression of that algorithm, just like the cake that you bake is an expression of the recipe. Okay, I do want you to read all this. So what is a keyword? The keywords are the words that define the language. Reserved words. They have a special meaning. You can't use those words yourself. You can't, if you're writing a program, decide that you're going to use the word if as your variable name. If is equal to 3. Okay. I don't know what that would mean, but you know. Or for. You know, for is a keyword. You can't use that one. You know, for is equal to 20. What I mean by you can't use it is it's reserved for a special purpose. Ifs are reserved for if statements. Fors are reserved for for loops. If you use them in any other context except that, it won't work for you. So you have a lot of latitude in the variable names you can create and the function names you can create, but there are, you know, 40 or 80 or so keywords that we're not allowed to use. So things like using and namespace and int and double and return. We saw all those last time, or at least we saw some of them. I think we used float. Same idea, variable types. So the keywords define the grammar of the language, are reserved, cannot be used as function names or variable names. Examples: if, else, for, while, using, namespace, return. All of those are keywords. And there are lots and lots of keywords. You don't have to know every keyword in order to be a good programmer. You know a good subset of them, you know, 10, 20 of them, and then you just look up additional stuff as you run into it. So using, namespace. Now std isn't a keyword actually, and it would be a different color if we loaded up the ID and we typed this in. Int, double, those are variable types, so those are keywords. CIN and COUT are not keywords. They are defined as part of the IOStream library. They are identifiers, but not keywords. So programmer-defined identifiers. Those are names that are made up by the programmer. Pay rate, salary, weight, height, calc_pi, you know. Those are things that are not part of the C++ language. You're making them up. So they're used to represent things. They are variables. They are functions. They are classes. So in their example code, they had some variables: hours, rate, and pay. This is one of those ask how many hours did you work, how much do you get paid per hour, and it calculates your pay rate. Yeah, we'll probably do something like that, you know, and then calculate overtime, that kind of thing. So, identifiers. Programmer-chosen words to represent variables and functions and classes and other things. Then there are the operators. Addition, subtraction, multiply, divide. And then there are some other fancier operators. That one and that one, which are used with CIN and COUT. Those are called stream insertion operators, or stream operators. Stream because COUT accepts a string of bytes being sent to it, and CIN reads a string of bytes from it. And the equal sign is an operator called the assignment operator. Copies data from the right-hand side to the left-hand side, and then multiply. So any symbol, pretty much, is an operator. There's another one. There's a single equal, which does assignment, and a double equal, which does comparison. And those stream operators those are the stream operators in action. Multiply, assignment. And then there's punctuation. Punctuation doesn't change the data, it just marks the parts of the program, it separates them. Things like braces and commas and semicolons are punctuation. I'm not going to write that down as a note, but each comma between a variable name up here, or between the arguments in a function. Semicolons, every line has to end in a semicolon. Let me rewind that. Every line, unless it's an if statement or a while statement or a for loop, all these statements at least are going to end in semicolons. Anything that does not exist before a curly brace. If there's a curly brace on the next line, the semicolon's going to break the curly brace. And I guarantee that that's going to be a common mistake in here. The Python programmers didn't have to worry about that because you didn't terminate your lines with semicolons. So this is going to be a little bit of a twist. It's going to mess you up. And I'll show you what I mean. Not that we've talked about it, but you have a function name, int main, and then after the function name you did a curly brace, and then you had some code, int x, int y. Then there are such things as if statements. If x is equal to y, that actually would not work, probably, because x and y don't have values. And then you can have some more braces, and then this code executes only if x is equal to y. So cout, same, /n. /n is the same thing as that ENDL, except the /n goes inside the quotes, and that ENDL goes outside it. Okay, that's great. But then if you look at your code and you go, well, my silly prof told me that I have to end everything in a semicolon, it's no longer going to work. That's not going to work. Every time you have a curly brace or you start a new indentation layer, don't put a semicolon in front of it. Similarly, if you put a semicolon here, that would break it. You don't want to put a semicolon there because the next thing after it's a curly brace. So the syntax, those are the rules of the grammar that must be followed when writing a program. The order in which things have to be specified. Variables. A variable is a named storage location in memory. It holds a piece of data. X is a variable here. There are three important things about variables. They have names, they have types, and they have values. So up here, int x, x is the name. The type is int, not ubt, and value is 0. So see, it actually turns out that Chapter 1 does have a lot of good stuff to it. So do read it. Quite often, Chapter 1 in these books is just the history of computing and stuff like that. But this one's actually chock full of good stuff. Variable definitions. To create a variable, you have to define it. And that's different from Python. In Python, we could just go merrily away and do, okay, well, I want x to equal 10. And I want a name variable that's going to equal Joe. That kind of stuff. That doesn't work in C++. C++ is what's known as a strongly typed language. Meaning that every variable must be given a type before it can be used. And once given a type, can only store that kind of data. So broadly speaking, three categories of data: ints, floats, and strings. Ints are whole numbers, and I know this is a review. I hope so. Yes, indeed I am. Awesome. Okay. So ints are whole numbers. Floats are numbers that have decimal points. And then strings are sequences of letters inside of quotes. So if I want a string, if I want a name, I can't just do this, n is equal to Joe. I would then have to define it, or I would have to preface it like that, string n. You can break it apart, you can do it in 2 steps, or you can do it in 1. But you have to define your variable before you can use it. It's okay to combine those into one thing. Once it's defined, you can't go around and change something else into it. You can't do n is equal to 10. Something we did a lot in our Python class looked like this. Don't write this down or anything because this is not C++, but we would do something like x is equal to input, and then we would do x is equal to intx. And what input would do is it would return a string and store it into x. And what this would do is it would take a string, return an int, and we would store an int into it. That would not work, just like this would not work. This would fail because n is defined as a string. Here, if this somehow, if there was something called input in C++ would return a string, and here we would be passing it into some kind of function that was supposed to return an int, we would get an error because it was a string. For one thing, we didn't define it. We didn't say string x or something like that. So if you had to do something like that, you would give 2 different variable names. String s is equal to input, int x is equal to intx, something like that. You just cannot reuse a variable with a different data type. And the editor is pretty good about telling you things. You're going to get spoiled, those of you who've wrestled with Python by Visual Studio. So when you're defining a variable, you can define more than one, and as long as they are of the same type, you can put them all on the same line. You can say double, and then I want 3 different variables of type double. What's a double? It's a big float. It's a float that's capable of holding, a large value. In our Python programs, we did not have to distinguish between small integers and large integers, or small floats and large floats. But C++ is an old language, and it's prehistoric. It's a modern language, but its roots go all the way back to 1970. And so it has some holdovers, which is one that you have to define the size of your variables, and you do so with the keywords. We will get to that point where I show you the small versions and the large versions of the ints and the small and the large versions of the floats. So a variable holds a specific type of data, so it has a specific type, it has a name, and then it can have a value. The definition specifies the type of data it can hold and the variable name. So hours, rate, and pay are all of type double. Double is a floating point type. The word double specifies that the variable can hold double precision floating point numbers. So instead of being like 16 bits wide and holding small numbers, maybe 32 bits wide and holding larger numbers. I forget what it's, 32 or 64. So input, processing, and output. Typically our programs follow kind of a sequence. The ones that we're going to be writing in here. We gather some input data. We ask the user for some input data, or we read some data from files on a hard disk. We process that data, and then we display the results as output. You display it to the screen, or you write it to another file. That's going to be pretty much the template for the vast majority of what we write. The programming process. Clearly define what the program is to do. Clear your mind, young Padawan. Close your eyes. Define what the program is going to do. Visualize the program running on the computer. This is a bit silly. Use design tools such as hierarchy charts, flowcharts, or pseudocode. Well, we haven't ever learned what a hierarchy chart is, but Some of our classes have seen flowcharts and pseudocode. Check the model for logical errors. Type the code. Save it. Compile it. Typically what people do is they jump to step 4 before even thinking about anything else. Correct any errors found during compilation. Wash, rinse, repeat. Run the program with test data for input. Correct any errors while running the program. Repeat steps 5 through 8 as many times. Validate the results of the program. They're kind of missing one though. Run the program with test data for input. Programmers typically run their program to prove that it works. You write a program that'll convert Celsius to Fahrenheit. You type in a Celsius temperature. You confirm that you get the right the value, and you go woohoo. You also need to test your program to break it. That's called debugging, or testing it. In a large company, you'll actually have a test department that is devoted to trying to break your code. And the reason for that is because if they can break it, that means that a customer can break it. Meaning that they type in something and the program crashes and they lose their data and they call you up and they hate you and they switch companies or whatever. It's bad if your program crashes. So
break it on purpose.
yeah. So part of testing is to try to break your own program. You want your programs to be bulletproof. And when we write our programs in here, there are going to be things that we don't really bother correcting that we should in order to make a bulletproof program. Like we're not going to really go to a lot of trouble to make sure that if they type in a word rather than a number, it's not going to misbehave. And we should. Procedural versus object-oriented programming. Procedural programming, kind of like a top-down, I'm going to list a sequence of steps. That's what a procedural programming is. I want to calculate somebody's salary, so I need a series of steps that calculate somebody's salary. What I need to do, I need to ask them for the number of hours, for the pay rate, and I need to perform a calculation, and I need to display the results. Okay, I have like 4 or 5 discrete steps, procedures. Object-oriented programming is when you process on objects, which are data, and then the means that manipulate that data. Like you might create an employee class, and the employee class has, as part of it, an hours worked per week. And it also has, the pay rate per hour. And then the means to manipulate the data, the functions that work on that employee class. Well, right now we only need a calculate pay function. But later that employee class may get larger and larger as we add more functionality to it. So it's a different way of looking at it. We're going to do more procedural programming than we do object-oriented programming in here, but I want us to move quickly enough so that we also get a good foot in the object-oriented programming door. If you go on to take Java, you start object-oriented programming essentially from day one. So it's Java came after C++, and so it built some concepts into the core that C++, C++ had to be backwards compatible with a completely non-object-oriented language C. So you don't have to do a lot of object-oriented programming in it. In fact, you can get away with not doing any if you stick to pure C code. But we are going to use C++. We are going to write objects and use classes. String is a class, for example. CIN and COUT are classes. All right. That's the end of that chapter. Let's go back and look at our notes.
Wait, so those aren't, so CIN and COUT aren't like functions of the IOStream library? They're classes of it?
I was wrong. They're not classes. They are objects. They're objects of the library. They're not functions. Yeah. Functions have the parentheses after them. So if you see something that's not no parentheses after it, then it will be an object of some kind. So why I am thinking about it. All right, this is a reminder. We're done with chapter 1, so you need to read it. At the very, very, very least, review the PowerPoint that we just looked at. But you'll learn more from the book. It's more explanatory. not download chapter 2? There we go. All right, Introduction to C++. Everything that first chapter talked about could really apply to a lot of different languages, although things like Python, you don't define the variable before you use them, but in most languages, or at least a lot of them, you do.
What's the word? Instant. Isn't there like another word that you use? Because remember how I kept saying like you define things and you were telling me that's not the word that you use for it in Python or something like that.
Yeah.
Instant. Something.
Declare an instance of, instantiate.
Yeah, that word.
Instantiate. Yeah. Instantiate is used mostly for classes, for objects. Yeah. But you're right, I remember correcting you. And now I don't remember the exact context except to say that if you declare a variable, that specifically means you're giving it a type. And we don't do that in Python.
Okay, so that's
Yeah.
what it was. Yeah, I kept
Right.
saying defining a variable. And you're like, well, we're not.
Yeah. Yeah. So if you declare a variable, that means giving it a type. You know, float the temperature. Int number of Legos. Name. String name. Stuff like that. So the parts, these are comments. // instead of hashtag like we were using. // is used in a lot of different programming languages that kind of have adopted it from the C++ language. So you'll see it in Java and other programming languages. Anything that's preceded by 2 slashes is ignored by the compiler, so it's not really part of the program. It's just there for you to look at.
That can also be used to help debug your program, as you talked about earlier.
Yeah. Yeah, absolutely putting good comments into your program is essential for understanding it, especially if you walk away from the program and come back to it a year later.
What did I do?
Yep. So then there are, and these are kind of unique to C and C++. You don't see these in Java or a lot of other languages, something called preprocessor directives. Preprocessor means that this controls something that happens even before the program is compiled. When you hit that compile button, the first thing that happens is a preprocessor checks your file for any preprocessor directives. And there's only a couple of them that we'll use. At the beginning, this is going to be the only one. But what this does is it goes and opens a file called IOStream and effectively pastes it right there. So although we don't know it, suddenly our file, when it's being compiled, is several hundred lines longer because it's got this IOStream library that got included into it. It's like an import statement in other languages, but it's also not like an import statement. It actually brings in the contents of another file. And other preprocessor directives, you can define things to replace other things. Let me give an example of that.
Is that where the concept of hashtags came from? Yeah.
I don't know how.
You know how hashtags work, right? So.
Yeah, I don't know how Twitter chose that to mean what it does, to use as a keyword or whatever. But, pardon me?
Instead of first only meant numbers, now it means something else entirely.
Yeah. So, do I have an old project, a recent project?
So without including the string library, would that code that you have in your PowerPoint work?
Let's see what happens if I comment this out. Stop it. Okay. Now it no longer knows what cout and cin are, although it's not flagging them as errors. So let's see if we actually can rebuild it. Rebuild all started, rebuild. Yeah, I suppose you could work. You're not supposed to. What? That's not supposed to work. I don't know how.
It should be whole world with a question mark instead of an exclamation point.
Yeah.
Like what?
Similarly, this one. If I comment that one out, then if I try to use a string, then there's a different string type that's built into the language, but it does not do all the things that, that we expect from the string class. Okay, that one's puzzling me. Well, anyways,
That's one thing we can, well, now I wouldn't say take out, because there may be something in that library that we need to use later on. So.
yeah, curious about leaving it out. Anyways, okay, so the preprocessor, that's not the only statement. There's another one called DEF. Or is it define? Yeah, define. And what this lets you do is say you hate the number 0 and you'd rather type in the word 0. And say you hate the word int and you want to call all ints Fred. So you could replace every int with a Fred. And let's define something to mean float. Barney is going to be our floats. Now this is stupid. And don't do this kind of stuff. But
What, is that for like encryption purposes?
it's not for encryption purposes. It doesn't change the way the program works. I'll give you one example of when you might really use it, or would have used it in the past before it was introduced into the language. But anyways, you're kind of defining your own language. You're kind of defining, you know, what you want it to look like. And back before the Boolean data type was added to the class, people would do this: pound define false as 0 and pound define true as 1. So that they could do things like this: int error is equal to false. And then later on they could do, you know, if something goes wrong, error is equal to true. That kind of code, that kind of thing. And then they could do, you know, if error is equal to true. And it made it a little bit easier to read than if you were saying error is equal to 0 and then error is equal to 1 and if error is equal to 1. Made it easier to read. Nowadays people don't do this too much. There are other things like something called an enum that you use to define values like that if you had to. And there's a data type called Boolean which gives you the trues and the false, so you don't have to do that so much. But, you know, if you're feeling freaky, you could go and replace every keyword in your language with something, and then the preprocessor would handle it, you know. Except for the fact that I added some stuff here that's not going to work like that. This would still compile, even though that says Fred, and these says Barney. I'm sorry?
What are the other libraries there are besides the IO stream?
Oh, there's so many.
Really?
Got a question?
Yeah, so I can never get this to run last time we did this.
Okay. Then let's take a break, and I will come back down and look.
Does the language change over OSs? Like if you operate on Linux, is it going to be different as opposed to Windows?
The core language does not change. The core language is meant to be, you know, platform agnostic.
Do some of the libraries change?
Yep, they have to in order to, you know, to work on the various operating systems. Back in the old days, each kind of computer that came out had its own version of C, and the width of an integer, you know, how many bits an integer was, and how many integers a float was, and stuff like that was different. But then they standardized them all so that at least the code should compile on all of them. But if you're, you know, if you're doing graphical windows popping up and stuff like that, there's no way that the code that does that is going to be the same on a Mac as it is on a Linux as it does on a Windows. So the libraries you bring in are written differently, even if the syntax of them will look the same. Does that make sense?
Sure.
Kind of like if you're just buying different ingredients, different spices to make your food in order to get it. So what we are doing, everything we do in here will work on anything that supports C++. We're not going to be doing anything platform specific. The Windows programming course that's coming out in the spring is very Windows specific, and it would not work on Linux or Mac. If you go to a different language, Java, that was really written from the ground up to be cross-platform, and so all the libraries are the same, regardless of which. But you can't do as quite as much. People don't write spreadsheets and video games, high-powered video games and stuff like that in Java because it doesn't run fast enough for those purposes. It's better to run something that was tailored specifically to that operating system. So that kind of stuff is written in C++.
And so what's pretty much different between an include statement and an import statement? I mean, I know.
When I said that there's a big difference, I'm not sure I should have said that. An import statement just sets things up so that you could use a class that's defined in that. Include will bring in anything. You could even have, new chunks of code hidden in there. Yeah, you could have a main, an int main inside a header file, and then if you did import that, then that main is part of this program now.
Oh, okay, I see.
That's how they make it where teams of people can work on the same program and stuff like that too, right?
Right, you can divide your project up into files, into separate files, and then you can also have header files that are shared between the projects. And so, you will have something called a source control system, where if I'm working on, the graphics library for my game, I will check out graphics.cpp, lock it. That means that everybody can look at it, but they can't make any changes to it while I have it locked. I make my changes and I unlock it, and now those changes are available to everybody else. So if you have a team of people, that's what you do. You have a version control library that lets you do that. And I know that Microsoft comes with one, and then you can buy others. Nowadays, people use, what's it called? The online one. I cannot believe my mind flaked on it. Git, G-I-T. You may have seen something called GitHub. It's a version control where you could have teams of people working over the entire earth working on the same thing because it's on the internet.
It's networked to the
Yeah.
internet. That's cool.
Right.
Well, seeing that whenever you do create a new project in Visual Studios, it says new Git repository has been created. So what exactly is a Git repository?
Oh.
It's a library on GitHub, isn't it? Or
Well, if you do an empty project and then create it in the console, it'll tell you that you just a new Git repository. Well, that's probably I'm using 2017. Sorry, so.
Okay.
It's in the-
You're seeing some cooler stuff than we are.
Oh,
Yeah.
wait,
So
hit-
if
hit view, sorry. Maybe you can view at the top, part left. Is there say internal terminal somewhere?
I doubt that the 2013 version had Git integration.
Oh, okay.
If you go out and look at GitHub, what GitHub is,
Development platform inspired by the direct from open source business. You can post and
you
it's
upload,
basically a giant library full of libraries.
yeah. You can upload your code to it, and you can say, I want anybody on the earth to be able to look at this code, or I only want specific people to be able to view this code. And then multiple people can edit it and do just kind of like what I was saying. One person can make changes to it. It keeps track of the changes so that if you need to undo some changes, if John the idiot made a mistake, you need to go back and fix it, you can go back to a version and find their mistake and fix it. And
Well,
so
I
the,
think they do like a lot of modding and stuff on this website for games.
yeah.
So I don't know. Just a,
Yeah, so you'll see lots of stuff out on GitHub nowadays. If you do anything open source, if you play with any open source code at all, people upload it to Git so that you can, multiple teams can be working on it, multiple people can be. So we've done a preprocessor directive. Anything that starts at a pound sign is a preprocessor directive. There's a couple more preprocessor keywords which I'll just mention. And that's pound sign if, or and #if def. So like say I'm going to define define Jeff's version. Then down here in my code I might do #if def Jeff's version. Then I will have some secret code in here. Cout. By the way, Jeff is awesome. And then indif. This code will only be in the compilation, in the results, in the executable, if in fact Jeff's version was defined. Typically what you do is you put your #defines in a header file, and then you, just by changing the header file, you control the way that this program gets compiled and works. And again, that's something pretty exclusive to C++. I wouldn't necessarily rely on it. So I'm showing you stuff that I want you to see it now so that if you go out into the real world and see it again, then you'll immediately recognize it. So just like we can define a kind of our own substitution language, our own macros with #defines, you can use #if def. One thing that, okay, I'm not going to even say that. Let's go back. So then namespace. A namespace, I'll show you what the namespace, the side effects. I need to kind of undo these changes that I've made to it. I'm going to remove my defines so that the program looks back the way it did originally. I guess it compiled. Yeah, okay. Easiest way to find out what something does is to comment it out and see what it breaks. So I'm going to take that out. Now all of a sudden, you better not keep working. I give up. It's time to go home.
Run it and see what it does.
Yeah.
Just because it runs doesn't mean it's...
Let's go to that empty project. All right, we're not going to include IOStream, but we're going to pretend that we did. We're not going to use the using namespace, but we're going to pretend that we did. So include IOStream, but it's commented out, so it won't really take effect. And then using namespace std, we leave that out. And then int main cout hi, followed by endl. Now it's doing it. I don't know what was wrong with that other code. System pause, so that we get our pause at the end. This is what I was expecting to see all along when I commented out IOStream. Without IOStream, we don't get the ability to use cin and cout. So that's why all those.
All the other,
The
endl and the system.
It's like it. If you do a, when you make a new project, you can tell it whether you use pre-compiled headers or not. And the way we're doing it should not be creating pre-compiled headers, but it's kind of acting like that stuff was cached in there so that it was bringing it anyways. I'm actually completely mystified. I don't have a good explanation for why it was behaving that way. But we see that cout and cin are not working because #include is not working. So if we bring them in like this, those errors go away. If we leave the #include, but we take out the using namespace, these go away. I mean, the errors come back. And that's because cout and cin are defined, but they are defined in their own namespace. So without this statement, we would have to prefix the name of that namespace to everything that was in that library. namespaces are part of the C language. I don't know when the using statement came into being. There's something similar to that in Java. It's just a shortcut. It says I don't want to have to type std : in front of everything that is a part of that library. So I am going to do this so I don't have to do that. Now, a lot of programmers don't want you to do this using namespace std, and they want you to type in std : everywhere. And if you go and you look online for C++ help, like you go to Stack Overflow or whatever, you'll see a lot of code that has std : and they don't use this using namespace.
Why?
Because when you do using namespace, you actually get a great big. There are a lot of things defined in std that are suddenly available to this without. Let's see if we can get a list of any of them. std : Here we go. All of these things are suddenly available to us without us expecting it, if that makes sense. We just thought we were making it easier to type in C out and C in, but it's also bringing in other things. It's like a library that's being brought in without us knowing about it, except the library actually came in when we did that. It's just it's being more exposed by doing that. So people say don't do that so that you're in absolute specific control over what you're accessing, and you know exactly where those things are. std, you know that cout is part of the std namespace. I'm lazy. I'm going to go ahead and keep doing this using namespace. If you feel like toughing it out and leaving it out and just making all the changes, you will earn my respect.
One quick question.
Mhm.
How do you, like how int and float are like keywords? Is string not a keyword? Because if you type in string, it doesn't, like it doesn't say.
String is a weird beast.
Let me try that.
I don't have # include string, so it brought a version of string in from somewhere. You can right click on something and do go to definition or go to declaration. What we see is that here's that type def. This is kind of stuff that's, this is in a header file somewhere called std, and it's defining a string as being a so-called basic string. Now, for some reason, basic string is not really used very much, and everybody uses the string class instead. Let's compare the two.
I guess it's just whenever I do use include string, like my string keyword doesn't, it's not like color coded as like
Right.
syntax.
Yeah. So, what's the difference between standard string and basic string? Basic string is a class template for making strings out of character types. std string is a type def for specialization of that class for character. String is an instantiation of, so it's a specialization of it.
Okay.
It's not a primitive data type. Some languages have the idea of a primitive data type versus a class data type. A primitive data type in the languages that support them are the things like the ints and the floats and the chars. Java supports the idea of primitive. No, it doesn't. C and C++ have primitive data types.
So that kind of
Java does too, actually. But C# and Python do not have primitive data types. Absolutely everything is a class in those languages.
I was watching this video on like object-oriented programming in Python, and like the guy was like, I guess he was overriding, like he was doing like dunder string, like he'd do _str, and he would make it, like he would override the string keyword and make it do something else. It was weird. I don't know.
Send me that video if you find it again.
Okay, that's fine. I think I would say
Okay.
22.
So we've got that, we've got that, and then every program we write has to have a main. If we wanted to be able to pass in command line parameters, which means that we wanted to be able to run the program from the command prompt like this and pass in things, you know how you can type in dir, you can type in dar, and then, you know, give it some command. I want everything to be sorted by date. Those are called command line parameters, and if you want your program to be sensitive to command line parameters and able to use them, you have to put something in between the parentheses in order to accept them. We're not going to really do that, so I'm not going to be putting stuff there. And then every block of code is defined by the curly braces.
Oh, so even the book tells you to make your main an int. The book tells you to do that as well. I know it doesn't matter, but it just tells you to make it an
Yeah,
int.
some languages are very specific about what main has to be. Java, it has to be a void. It will not return an error code back to the program that launched it. In C and C++, you can make it an int, which means that when the program is done, it will return a value. And if you called it from a batch file or a CMD file, you can actually get that value and use it in, you know, whatever program called this one.
Oh, okay.
So that's why you have that word there. So special characters. We've seen that one. That's the comment. We've seen a hashtag. It begins a preprocessor. Those guys we will see in other uses, but right now they mean enclose the file name in a $include. They have a more specific meaning. They mean search the include path for the directory. If we did this, if we put include and we put quotes there instead, or let's do another one. $include myfile.h. The quotes mean that there's a file in the same directory as the CPP. It won't go searching for it anywhere else on the hard drive.
So it has to be in that source file.
Right, it has to be in the same directory. So all of the C library are stored elsewhere. So we say go ahead and search, you know, the include path. That's what the angle braces mean.
Where does the include path go? Does it go over the internet? Do you need it?
No, it doesn't go over the internet.
You just have to have. Is it in any compiler or?
It is defined. Let's. I don't know how to. Let's. What? Well, this is always just a Google. Include path for C++ or for Visual Studio. To set this compiler, open the project's property pages. Click the C++ folder, click the general property page.
So if you were to download like more things,
Then you might need to modify your include path to incorporate your new directory.
Oh, yeah, you have to do that for like
So
like the Java C. Like if you try to run Java C in the command line, at first it would say it couldn't find it, but you had to add it to the path.
Yeah, slightly different. That's adding it to the operating system path, but that's correct. And so right now, we cannot do the compilation that Visual Studio does. We cannot run the linker and CC for compiler, or is it VCC? I don't remember. But we could go and we could find a path to those things, and we could add them to the path. Microsoft gives us a command file or an executable which launches a command prompt in such a way that everything is already set up so that you can compile from the command line, and I don't remember how to get to that. all I did is go into Microsoft Visual Studio folder. I'm looking here. Man, there's a lot of stuff. CL. CL is the C compiler. And since it's not mapped in the operating system path. If you go to the command prompt and you type path, you can see that there's a search path. And none of them are going into the directories, and so we can modify that. Just Google up path space Windows 10 and you'll get instructions for how to change that path. It differs from version of Windows to version of Windows. Alrighty, opening and closing parentheses. They are used when defining a function. Open and close braces define a block of code. Open and close quotes include, you put strings inside of them, and a semicolon ends a programming statement. Alright, the cout object displays output on the computer screen. You use the stream insertion, I love that term, operator. I'm just going to say arrow, arrow, or greater than, or less than, less than, to send output to cout. So for example, you do that, cout programming is fun, and it would display that message to the console when the program ran. You can send more than one thing to it. You could do cout followed by hello, space, followed by there, and it's going to print hello there. Or you could do cout hello with a space and cout there, and it will still say hello there, all in one line. You Python programmers have seen it to every time you did a print and went to the next line. Cout doesn't work like that. Unless you use that ENDL or you send a slash into it, it's going to always be on the same line. So if I do this, let's get rid of that. So I do hi, and then I do cout hello, and then I do cout goodbye. Those are all three going to be on the same line. Hi, hello, goodbye. If I want them on separate lines, I need to either put /n, that means go to next line, \n, the slash above the enter key, or I need to use that ENDL keyword. It's not really a keyword, it's an object. Again, if you're curious about things, you can right click on that and go to definition. You'll see how it was defined in C. Usually it's, it's above our level of comprehension at this point. And if you want help on it, I believe you can just hit F1. And it will load up. And this does require going out to the internet. It doesn't load the help files locally. So what is ENDL? It tells us. Terminates a line and flushes the buffer.
Oh, that's a nifty function.
Yeah. So here's our example of it. So it's kind of cool to be able to get help on anything just by highlighting it. What is an INT? I'm going to highlight it. I'm going to click F1. It loads up the MSDN help files for the fundamental types of C++. There are integral types, which are integers, which include longs and shorts and ints and chars and longs, and then there are floating point types. Okay, let's keep going. So this produces one line of output. Programming is fun. Since there was no /n, no ENDL, it's all on one line. You can use the ENDL, I love this term, manipulator, to start a new line of output. This will produce two lines of output. Programming is, ENDL, fun. You do not put quotation marks around ENDL. You do if you do /n though. It's an L and not a number 1. Common typo. Escape sequence. Why are these things called escape sequences to begin with? Because we're looking at a string of letters, but then when it hits a backslash, it says, oh, by the way, the thing that follows it gives us a special meaning. It escapes its normal processing in order to do something else. You can have /t for tab. You can have /n to go to a new line, and I'm spacing out on the other ones. We'll probably come across them pretty soon. So programming is,
They're all called escape sequences?
yes, that's correct, right.
So anything followed by that backslash like that?
Which is a problem if you actually want a backslash in your output.
Right.
So if you do that, if you want a backslash in your output, like you want to say, you know, your C drive, like that, then you actually do that. This says, okay, what's coming up next is an escape sequence, and this goes, haha, fooled you, I really just wanted a slash. Same with quotes. If you do /quote, it treats it just like a quote. But why would you do that? Because otherwise, it thinks it's an end quote. Right. So if I go, my name is Mud, but I wish that I could put double quotes around it, that's all kind of messed up. So I got to go back and I got to use escape sequences to convince it that those quotes are not part of the syntax of the language. They're part of the string. That fixes it. You can do single quotes, backslash, and double quotes all in the same way. Guess those are worth listening. Escape sequences. /n is a new line. /f means form feed. I don't know what in the world people would use that for in modern days, but when you were using printers, it would kick out a new page. We're just going to skip that one. /t does a tab.
Are you talking about when the papers were connected?
Yeah, when you had scrolling pages. Yep. Then you have // which just does a single slash. /quote, which does a quote. /apostrophe, which does an apostrophe.
What happens if you just try to do a normal apostrophe?
A normal apostrophe will normally work. If you wanted to do this, my name is Mud, and you wanted single quotes around it, no prob. You don't need to do that escape sequence. It won't break it. However, there's another type of declaration that requires single quotes, and that's for something called a character. A character represents just one letter, like that. If you try to put more than one letter in there, it's not correct. Even if it's not calling it a syntax error, it should.
So it's now a string.
So a string is a series of characters, actually. So what if you wanted that character to be that? Well, that's not going to work, so you use an escape in order to convince it that that apostrophe really is an apostrophe.
Is that how you would like program maybe like a keyboard input for like a controller or something like that? Maybe.
Usually you'll have some kind of library that the keyboard, that the controller will use. So #include inserts the contents of another file into the current directory program. It's a preprocessor directive. It's not part of the C++ language. Do not place a semicolon at the end of the #include line because it's not a C++ function statement. Yeah. Variables and literals. The variable is a location in memory. It's got a name, got a type of data, and it's got a value. You have to define it before it can be used. Int number. Number is equal to 5. Or you can collapse those two things into a single statement. Int number equals 5. Literals. Literals are values that are written literally into the program's code. The words hello there. That's a string literal. The number 12. That's an integer literal. So in our code out here, if I did x is equal to 1, 2, 3, 1, 2, 3 is a literal. Kind of a weird term. You're not going to hear that over and over and over. But what does that mean? It means that it's something that's not typed in by the user. It's something that you set. And it's not a variable. Some textbooks call it an unnamed constant. So 123 is an unnamed constant that has a value of 123. It's a literal. Then string name is equal to Joe. Joe is the literal, is a string literal.
That would be good to know in Python when it kicks out that error that talks about the string literal. I didn't know it was talking about.
And you can have floating point literals as well, 1.23. Today we sold, and bushels of apples, those are string literals. They defined apples to be 20, so that's an integer literal. Identifiers. Identifiers are the program-defined names, variables and functions, and class names. There are rules about what an identifier can and cannot be. An identifier cannot have spaces in it. So if I wanted this to say my age equals 3, that's not going to work because I put a space in it. Delete the space. Also, they cannot start with numbers. Well, okay, great. I forgot to put the data type. But there, that's still an error. So if you do 2017 tax returns, that's an error. You can't start an identifier with a number, with a digit. It has to start with a letter. So our rules for identifiers for variable names. No spaces. You can use underscores. Right. Can't be a keyword. Cannot start with a number. Really, really, really long time ago, they were limited in length. Like only the first 8 characters of the name mattered. And if you made it more than 8 characters, it was okay. But then if you made another one that had the same first 8, it thought it was the same thing. And that's not true anymore.
Do you prefer underscores or do you like camel casing better?
I kind of like underscores better, honestly, but that's because how I started. Camel case came along later. So the question is using underscores versus camel case. Camel case is when you do something like this. My weight in, or my height in inches. It's called camel case because some of them are capitalized and some of them are not. So you have humps in it. The other thing you could do is, I'm going to take out the word my. That's exceedingly silly. But height in inches as opposed to height in inches. Doing it like this is so ingrained into Java programmers that I've given up, and I do it that way whenever I write a Java program. Pardon me?
It's harder to read.
I think it's harder to read.
Like the Java convention that wants you to do start your variable with a lowercase.
Yeah, everything's supposed to start with a lowercase.
And everything after.
And everything after it's got an uppercase letter. So a lot of people do that now. The Java convention has kind of taken over programming. A lot of people name their variables that way. You can even start things with underscores if you want, if you ever think of a reason to do that.
So is Python the only language that does underscores, like the first 2 underscores are like, I guess?
Mean something for defining the class. Yeah, normally what people use underscores, prefixes, is to mean that it's a variable that they are defining and they're using, but they don't want you to use. It's kind of a hands-off. It's like putting a red flag on it. So this would be bad. To fix it, we would just reverse it. Tax returns 2017. If you felt like specifying a year to begin with. All right, we may need to actually get to doing some programming pretty soon. We've been here an hour and a half, well, an hour and 15 minutes. Let's take a short break. Anybody who needs to use the bathroom or run to the Coke machine or whatever, please feel free to do so. Let's reconvene in 5 minutes. One type of identifier, function names are another. They follow the same rules. You can't start a function with a number. So rules for identifier names and other identifiers. You should use meaningful variable names, meaning that what I do in this class is bad. I should not just be slapping down X and Y and N and stuff like that. I should actually be typing out name and longer variable names. Within reason, the longer the better. The only reason I use the short variable names is because the shorter the variable names, the easier it is for us all to type them without making typos.
And faster the example.
Yeah, so like if I type HT for height, rather than trying to figure out whether it's GTH or GHT or whatever, you know, and then the program goes along. But in your real world programming, don't just use single letter variable names with a few exceptions. If it's just a little simple loop counter, if you're counting I from 0 to 10 or something like that, yeah, using I or whatever is just fine for a single variable. Keywords. All right, there's a whole bunch of them. Skip. Variable names. A variable name should represent the purpose of the variable. Items ordered. The first character needs to be either a letter or an underscore. After the first character, you can use other letters or numbers or underscores. You can also use dollar signs, I believe, and no book ever tells you that. So if you really want to, you could say, you know, some variable names. So put a 10. Well, that's goofy.
You can't use exclamation points or question marks.
Right. Dollar signs and underscores are the only two punctuation you can use in variable names. And the books all mention underscore without mentioning dollar signs.
Is there a reason for using the dollar signs?
No.
There's not a reason that you can, or?
Well, you could.
I mean,
Like, you know, you could
is there a
do
reason they did it initially, or?
float sales. You know, you could do that. In some languages, dollar sign meant that you were declaring that variable to be a string. So if you did name dollar sign, the dollar sign meant that it was a string automatically. C was never like that. So whether are these valid or not? Let's move these over so that we can't see the yes or no part. Stop looking. All right. Oh, great. Anyways, okay. Does that one look good? Yeah, it looks good. There's no spaces. There's no illegal punctuation. It doesn't start with a number. It's good. How about total underscore sales?
Yeah.
Also good. Total dot sales?
No.
That's bad because it's got something other than an underscore. Fourth quarter sales? That's wrong because it starts with a number. Total sales. This slide says that it doesn't work, but it actually does. So I'll never ask you that on an exam. I wonder if it's platform specific. You know, if Microsoft decided that dollar signs are cool because Bill Gates used to write versions of BASIC. That's how Microsoft originally got their start, is writing versions of BASIC for other types of computers, like for the Apple and for Ataris and stuff like that. Integer data types. An int is a whole data type, a whole number, 12, 7, negative 99. And C++ having its roots back into the prehistoric times of programming, there's like 20 different kinds of ints, as opposed to Java, where there's just 2. Really, all I want you to remember is that there are ints and then there are unsigned ints. An int is a number that consists of 4 bytes. It's 32 bits long, so it can go up to about 2 billion. An unsigned int is one that can't go negative. A lot of languages don't have the concept of an unsigned number, but this one does. So if you do unsigned int, you get numbers that can be twice as large as the normal data type, but they can't be negative. So the range of an int can be negative 2 billion to positive 2 billion.
So you would do that for something like time or age or something?
Yeah, something that you knew was not supposed to be negative. Or you could just blow it off and always use int. But right. Yeah, so unsigned ensures that that data type will never be negative.
Long int looks the same as int.
it says that it is. So if you're going to, and again, these would differ on every different machine you used, the number of bytes of an int versus the number of bytes in a long could differ. And you never knew whether they were going to be the same or not. An int could be 2 bytes and a long could be 4 bytes. They could both be 4 bytes. I guess they've standardized on them both being 4 bytes. If you want a big long, if you want a big int, you call it a long, which is absurd. I hate saying it. But, so if you have ints, you have unsigned ints, and then you have longs, which can be huge numbers, larger than 2 billion. So let's just define our little rules. Ints go from plus or minus 2 billion. That's the maximum value. Unsigned ints goes up to about 4 billion. From 0 up to 4 billion. And then a long is just one huge number. Yeah. Thousands, millions, billions, trillions, I don't know. Huge numbers. If you're the wonky type, an int is 32 bits, while a long is a 64-bit number. That doesn't mean that you can't use long if you have a 32-bit version of Windows or whatever. It's up to the compiler to make sure that that the longs work. It's not dependent upon the operating system. Really itching to actually get us into some kind of programming.
Always the bad thing about the first couple chapters.
All right. Let's do the standard early program of writing a payroll program, which will calculate your overtime pay. If you've taken another programming course, you have probably already done this. So make a new empty project. I'm going to call this one payroll. And we're going to throw a few things in that we haven't seen, specifically maybe if statements. So now that I created a new project, an empty project, I come over here to source files, right click, add new item. You could leave it source.cpp, but it'd be much more awesome to call it payroll.cpp. I'd like for everybody's code to contain their name and the date. So let's write a description of what this is going to do. Ask the user for their pay rate, their hourly rate, and the number of hours. Calculate their total pay, which is their regular pay plus any overtime bonus, where overtime is defined as any hours greater than 40.
Is there any the multi-line comment in the C++?
There he is. Right. Yeah, I may as well show the multi-line comment because I'm prefixing // in front of absolutely everything. It's just the same as it is in Java. So if I had wanted to, I could have started all this stuff off with a /*, and then I wouldn't have to keep prefixing the comment character on every single line. So overtime is defined as any hours of greater than 40. And the overtime bonus is 50% of the pay rate. And there's more than one way of calculating this thing. I'm just going to go with one way, and if you're convinced it's wrong, you're not correct. It's not wrong. Just be aware that there's more than one way to think about it, and you could perfectly implement it in another way. But I did have people insist that my way was wrong because they knew how to do it, and yes, they knew one way of doing it. And we had to program it both ways and show that it got the same answer as to what I am going to do. So we need to do our boilerplate type stuff. # include IOStream. I don't think we're going to need strings, but I'm just going to get in the habit of bringing in the string class no matter what. And then I want to do using namespace std, so I don't have to type that std : in front of everything. Int main. The last thing is going to be my system call to the pause command, so that it'll say press any key to continue. All right, that's my boilerplate. So we need to ask the user for their hourly rate and the number of hours. Let's tell them what we're doing. Payroll or pay calculator /n. The slash being the one above the enter key, the backslash. Cout.
And you don't care if we use /n or inline, right?
No, nope. My rule of thumb is if I already have a string open, I may as well just tack on /n. But if I actually have to do, if I just wrote out, don't type this, if I just wrote out the value of a variable, then if I'm going to do that, I may as well do ENDL just to be doing it the C++ way. There's no reason for choosing one or the other, in my opinion. Okay, so how many hours per week? ? We did not define our variables. You don't have to define your variables at the top of a function, but a lot of people like to do that. That way you know where to look in your code. So up above those things, right underneath int main, I know that I'm going to need a variable to contain the number of hours and the pay rate and the total and the bonus, something like that. So I'm going to need several variables, but for now I'm just going to stick with the hours. I could call it hours per week, and the rate, which is the hourly rate. Now we have displayed that message. We will read in whatever they type into hours. So CIN hours. Now I'm going to do the same thing for the pay rate. Cout. I'm going to put a blank line there just to make it a little bit easier to read. Cout. How much per hour? That's not very precise. What do you earn per hour? And then CIN into the rate. So now we need two more variables, or three maybe. A base pay, a bonus, or an overtime bonus, and an overtime hours maybe. There's always more than one way of doing this, and then a total pay. So let's define a base pay, and it's equal to the hours times the rate. Now let's define something called overtime, which is equal to 0, but it may be larger than 0. So we're going to use an if statement. If they've worked more than 40 hours, then we're going to set overtime equal to hours minus 40. So if hours is greater than 40, I'm starting a new block of code, so I'm using a curly brace, then overtime is equal to hours minus 40. Now we can calculate the bonus. The bonus is equal to overtime times 1/2 of the pay rate. And we're doing it step by step. You could actually write one line of code that would calculate all of this. I don't see any advantage to making it as concise and indecipherable as possible. So let's do a float bonus, which is equal to overtime times the rate times 0.5, or divided by 2. Either one would work. And then the total pay rate is equal to the base pay plus the bonus. Now we have this information, we could write it out. Cout base pay equals, followed by a $, followed by an end quote, and an arrow base pay. I should have compiled it and tested it before then. I've written like more than a page of code. Writing more than a page of code without compiling it is kind of silly, because it means that there's going to be more errors to correct at one time. But anyways, and then cout,
Does it matter if the 0.5 is, I guess.
if there's a 0 in front of it, no.
No, I was just asking if it was like, if it needed to be in parentheses, but it tends to happen no matter what.
Parentheses are useful, but they're not useful in this specific case. Parentheses force something to happen first. If you think that it makes it conceptually clear to put it in parentheses like that, I can totally dig why you would do that, but it doesn't change the way it works. Does that make sense?
Yeah.
Sometimes the parentheses are just for your peace of mind. So base pay is equal to $, followed by the base pay. I forgot the E and DL. I'm going to go back and modify that line, E and DL. Bonus is equal to $, arrow, bonus, E and DL. And you know what? We might not even want to print this bonus if they didn't earn one, but in which case we could use another if statement. But we'll leave it there. And then the total is equal to $, end quote, arrow, total, arrow, E and DL. I'll bring the code back up in a minute, sorry. I just wanted to make sure that it did in fact run. Okay. All right. If I need to scroll up or if I need to print out the beginning of it, let me know. I just deafened the people listening with the microphone by hitting it. If I leave this off, if I'm not initializing overtime, then by the time I come down here and I calculate this, the bonus is equal to overtime times that, it's possible it doesn't know, overtime doesn't have a value. Honestly, it actually does, but it has a random value.
It does have a value?
Well, let's find
Yeah,
out.
it does from the if statement, but it says that it doesn't. It won't let you do it. It'll let
N10. Okay, so it blew up. The variable over time is being used without being initialized. Runtime check.
If you continue it, it's like, it gives you like a weird answer.
Yeah. So this code is compiled in debug mode, which means that the compiler adds a whole bunch of checks into it to try to help you. If you compiled it into release mode, it's possible that we wouldn't get any kind of error message. It would just generate a horribly wrong answer. So other languages won't even let you compile if you're trying to use something that hasn't been initialized. The Java compiler catches all those and forbids you. So, yeah, there we go. That's pretty cool.
Wait, so can you print out what overtime is?
Yeah, let's print out what overtime is.
I wanna know.
Cout overtime hours equals overtime. Let's just find out what that is. Here's the line that I added here for debug purposes. I'll probably remove it. Although, yeah, I think the user may want to know how many hours of overtime they earn. Continue. -1 exponent to the 8.
So what generates, like what, I don't understand.
It's pointing, well, you know, every variable is pointing to a space in memory. It's just using what is ever is in that memory
Okay,
without having assigned a new value to it.
that's crazy.
It is crazy. And since it's compiled in debug mode, it is putting a very specific value there. Every uninitialized variable has the same weird value in it, just so that you can try to eyeball it and catch it. But when you compile it for release rather than in debug, then you have no idea what's going to be there. Okay, so that's an example of writing a program with an if statement. Our slide. Let's see if they show us a difference between a float and a double in the PowerPoint. Floating point data types. Floating point data types, float, double, and long double. They hold, quote, so-called real numbers, numbers that have decimal points. They're stored in a different format inside the computer than integers are. They consist of a mantissa, which is a number, and then an exponent. So they're stored in a format similar to scientific notation.
What did you say? A mantissa?
Yeah, the mantissa is like if you have 3.8 e to the 23. 3.8 is the mantissa, and 23 is the exponent. Just the terms for those two things. So every floating point number has a certain number of bits for the mantissa and a certain.
Does that read as scientific notation, or is it 3.8 times 10 to the?
Yeah, it is actually 3.8 times 10 to the 23. That's what the E stood for.
Okay.
Right.
All right.
Which you could rewrite as 3.8 e to the 23.
Right.
So our floating point types. A float is 4 bytes long. Now that's a large type. It can hold a number of up to 3 followed by 38 zeros. That's pretty large. But then there's a double precision called a double, which takes up 8 bytes. And that's a 1 followed by 308 zeros. Huge numbers. And then you can do a long double, which is the same thing. And here again, I kind of wonder about the sanity of the people who decided these things. But anyway, so there are floats and there are doubles. You could use doubles all the way through your program, or you could use floats all the way through your program if you're sure you're not going to use something that has an exponent value higher than 38.
Is there a way to eliminate the scientific notation and just to give straight, just to give it?
If you don't want, choose integers, if that's the case. Choose to use integer
Well,
types.
I mean, if you want like a decimal though, that just repeat, like if you were to like write a program that did pi to like so many decimal places, like,
You can specify how many decimal places you want printed out.
okay,
Yeah,
alright.
yeah. When you enter a floating point value, you can enter it just in standard 31.4159. This is in the code, not in data entry when the program is asking you for your age. Or you can use exponential notation, 3.14 e to the 1. Here we go. Floating point literals are double by default. I guess I'm going to switch over to, my advice would be to make everything double rather than float, just so that we don't get any warnings about conversions between doubles and floats. Why am I saying that? Because every number that you type in that has a decimal point is considered by the compiler to be a double rather than a float. And so that 0.5, it decided was a double. Now a double is overkill for holding 0.5 because it could have something that was 308 zeros long. But that's the decision that the compiler writer made.
Does the compiler still use all of that space, or is it?
Yeah. Yeah.
Oh, okay.
However, you can force any number like that to be a float by tacking an F on to it. If I wanted to modify that code to get rid of the syntax of the warning that you were getting back there, we could do that just by putting an F there. The other way would be divided by 2 rather than multiply it by 0.5, because then we wouldn't have a floating point number in our code at all. But to get rid of that warning, the other fix would have been to change everything from float to double. All right, we need to come up with some programming assignments that we need to do based on the concepts that we've already covered. Let me look see what I did last semester and see if we like those or if we want to come up with new ones. Okay, so for our homework, let's just write a few kind of simple programs. One is the classical convert a temperature from one format to another. So ask the user for a temperature in Fahrenheit. F stands for Fahrenheit. Then display the temperature in Celsius and in K, which stands for Kelvin. I'll save you the time of looking up the formulas. Celsius is equal to Fahrenheit minus 32 in parentheses times 1.8. Nope, divided by 1.8. My mistake. And then Kelvin is equal to Celsius plus 273. Close enough. 0.15 if we want to be really anal about it. Okay, so that's one program I want you to write. Ask the user for a temperature in Fahrenheit and display the temperature in Celsius and in Kelvin. And then again, ask the user for a weight in pounds. Display the weight in ounces. You look this conversion up. Or text me and I'll give it to you, you know.
It's 16 ounces to a pound.
Yeah, that one's not real challenging. Ask for a weight in pounds, display the weight in grams. You may still have that one memorized, but most people won't. All right.
I want to say it's like 248 or something like that.
2.2 pounds per kilogram, or 454 grams
That's what
per
it is.
pound.
That's what it is,
Right, yeah. You can put both of these you can do two separate programs, or you could put them all in the same code. I don't care.
Didn't they go in the same project at least?
Yeah, you can just stick them both in the same project. That's totally cool.
We should do a density thing with them both, since it's weight, or no, never mind, it's,
Yeah, if you want to make it fancy, you could give it a menu. Do you want to do A or B? Yeah, and we'll get to that point. But, yeah, for now. And just to make things easier, I'm going to include the sample code from our code here as a page 2 of the programming assignment.
Isn't 0?
We already did 0. 0 is install C++.
Oh, well, were we supposed to turn anything into that?
Just upload something saying you did.
Okay.
Yeah.
Let me just upload my whole project.
Yeah, I had mine already installed from last semester, and then over the last 2 days, I just installed Ubuntu
Yeah.
on my hard drive, and when I did it, the first time I did it, I messed up the live USB, and so it erased all, or when I went back, I had to reinstall Windows on it.
Yeah.
And I had all my files saved, so I have all my stuff, but I have to go back and re-download all my applications and programs. So
Yeah.
that's why my computer's at home, sitting on the charger.
Yeah. And so when you're done, you can just give me the CPP files. You don't have to zip them all up. But if you want to give me the entire project as a zip file, I'll take it either way.
Did you want us to upload the code from today?
Yeah, let's make a Dropbox for that. Can everybody read Word docs, or do I need to give PDFs as well?
No, I'm okay on that.
If anybody has problems with the Word docs, let me know. I'll upload PDFs as well.
I was having a question. How did you go to where you found your source file?
From inside C++,
Yeah,
let me show
did
you.
it in the Explorer from Visual or whatever.
Yeah. Okay, so if you want to find your file, your folders, you go over to the Solution Explorer, which if you've accidentally closed it, as I often do, you can find back under View Solution Explorer. And then just you click on Solution and do Open Folder and File Explorer. You might even be able to do that on source files. Nope. Okay. Do it on the solution itself. Open Folder and File Explorer, and then it's the one with the same name.